Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 17 Circles. We will be discussing all the concepts with examples and solve questions from exercise 17a. Hope you all are ready. Let's begin. Circles. Circle is something we have been studying from our KG classes. We have been studying about shapes and circle is a shape. Yes. Now what is a circle? Here, if I am taking a point O, from this point O, all the points which are at equal distance when joined together will be getting the shape circle. Okay. Therefore, a circle is defined as a figure obtained by joining all those points in a plane which are at a constant distance from a fixed point in the same plane. We have been studying about circles, area of circle, perimeter of circle, circumference of circle, radius, diameter. All these terms are familiar to us. Now, from this point O, when I draw a straight line to any point on the circle, I will be getting the radius. So, this is radius. Okay. Perimeter of the circle. So, the perimeter of circle is known as circumference. Okay. Perimeter of circle is known as circumference. We know to calculate perimeter and all. We are not discussing that here. Now, this fixed point is the center. This also we know. Now, if I draw a line from any 2 points, I am taking 2 points A and B. I am drawing a line connecting these 2 points. Okay. These 2 points should lie on the circle. Then this line is called chord. This line is called chord. You can construct any number of chords. So, this is a chord CD. CD is also a line drawn from one point to another point in the circle. This is a chord PQ. PQ is a small chord. Okay. All these are chords. We have studied about a chord which is more familiar to us. The biggest chord in a circle. Here, I am drawing a chord ST. Okay. This chord ST is the biggest chord in the circle. And this chord is called the diameter of the circle. In this case, SOT is the diameter. Do we have only one diameter? We can make any number of diameter. Only condition is that it should pass, the chord should pass through the center O. Okay. So, here we have radius. What is radius? Radius is a constant distance from the center of a circle. Circumference. Circumference is the perimeter of circle. Chord, a line segment joining any 2 points on the circumference of circle is called a chord, and diameter. Diameter is a chord that is passing through the center of circle, and diameter is the longest chord. These are the basic things we know about circle. Okay, all of these we are familiar with. Yes, we have studied in our previous classes. What are concentric circles and equal circles? First, let us discuss concentric circles. Now, for a circle, we know there is a fixed center. Okay, the distance from the fixed center is the radius. Okay, we have another circle. This is the center of circle. This is a bigger circle of greater radius. Here, the length of this radius is greater than the length of this radius. So, when radius increases, the size of the circle is increasing here. Now, when I am taking the centers of both these circles as same, okay, both these circles have same center. If I say that, in that case, we will be getting concentric circles. So, here I have drawn 1, 2, 3, 4 circles. So, these 4 circles have different radii. This is the radius of first circle. This is the radius of second circle. This is the radius of third circle. And this is the radius of fourth circle. So, in this figure, it is clear that all these 4 circles have different radii. What is common to them? All of them have O as the center. So, this is what concentric circle is. When you take concentric circles, they will be having different radii but common center. 2 or more circles are said to be concentric if they have same center and different radii. From the figure it is clear, right? Now what are equal circles? So when it comes to equal circles, the circles are said to be equal, or we call it congruent if they have equal radii. So in case of concentric circle, it is not necessary that we should have same radii, but when the radius is same. Here we have 2 circles of centers. This is radius of the first circle R1, this is radius of second circle R2. So if these 2 circles are equal, then their radii will be equal. R1 will be equal to R2. Or the converse statement, circles are said to be equal if they have the same radius. Clear? So these are concentric circles and equal circles. Let us understand what circumscribed circles are. A circle that passes through all vertices of a polygon. Here we have 3 circles given. Inside these 3 circles we have 3 other polygons. Okay, what is a polygon? Polygon is a figure that is made up of straight lines. Yes. So the smallest polygon using 3 sides, 3 lines, we can make a triangle. Then using 4 you can make a quadrilateral. Using 5 you can make a pentagon. Using 6 you can make hexagon. Hexagon and pentagon are cases when all the sides are equal. If they are not equal, we can call this a 5-sided polygon. This is a 6-sided polygon. For a 4-sided polygon, when all the sides are of equal length, we call it square. Okay. Now in this figures, we have the first figure, we have a triangle. So this triangle corners, when you check the vertices of the triangle polygon, here we have one corner, here we have one corner, and here we have one corner. So all these vertices are touching the circle. Yes. So here this circle will be called a circumscribed circle. That is, the circle touches the vertices of polygon. Here again, in this quadrilateral, we have vertices. These are the vertices. Yes. And the circle touches all the vertices of this figure. The circle touches all the vertices of this polygon. So here again, this circle is a circumscribed circle. Now, when you take a 5-sided polygon, this is a pentagon, or we are taking a 5-sided polygon. It is not necessary that we are taking a pentagon. When you have a 5-sided polygon, and these are the corners or the vertices of the 5-sided polygon. These vertices are being touched by the circle. Yes, the circle touches all these vertices. So again here this is a circumscribed circle. Okay, the center of the circumscribed circle is called circumcenter. This is the center of this circle. This is the center of this circle. And this is the center of this circle. The center of a circumscribed circle is called as a circumcenter. And the polygon is called inscribed polygon. Here this ABC is an inscribed triangle. A triangle that is inscribed within the circumscribed circle. Okay. PQRS. The quadrilateral PQRS is an inscribed polygon inside the circumscribed circle. And here EFGHI. EFGHI is a polygon, is a 5-sided polygon, and this is inscribed polygon. Okay, this is a 5-sided inscribed polygon in the circle, in the circumscribed circle. Understood? So this is the idea about circumscribed circle. Next is inscribed circle, just the opposite. In the previous figures, we had the circle outside and the figures, that is the polygons inside. Here we are having the polygons outside and the circle comes inside the polygon. Okay, a circle that touches all the sides of a polygon. When you consider this, ABC is the triangle and the circle touches AB at this point, BC at this point and AC at this point. We have 3 sides and the circle is touching the 3-sided polygon at 3 points. Okay, it is touching all the sides of this polygon. Okay, so this circle is an inscribed circle. Now, when you come to this case of quadrilateral, we'll take PQ, RS is the quadrilateral. Here we have sides PQ, QR, RS and PS. Okay, so the circle is touching at this point on the side PQ, at this point on QR, at this point on RS and at this point on PS. Okay, this circle is an inscribed circle in the quadrilateral PQRS. And here we have a 5-sided polygon E, F, G, H, I. And the circle is an inscribed circle. The circle touches the side EF at this point, FG at this point, GH at this point, HI at this point and EI at this point. Yes, the circle touches all the 5 sides of the 5-sided polygon. Okay, now the center of circumscribed polygon, we called it the circumcenter. So here the case is in center. For an inscribed circle, we call it in center. This is in center, this is in center and this is also in center. And the polygon is a circumscribed polygon. Okay, in the previous case, for a circumscribed circle, we got inscribed polygon, and for a inscribed circle, we will be getting circumscribed polygon. So this polygon, so here triangle ABC, polygon ABC is a circumscribed triangle. PQRS, quadrilateral PQRS is a circumscribed quadrilateral, and this polygon, 5-sided polygon is a circumscribed polygon. 5-sided circumscribed polygon. Clear? Understood? So, these is the ideas about circumscribed circles and inscribed circles. Circumscribed circle, just the opposite, we have the inscribed circles. Okay. In circumscribed circles, we had the circle outside and the polygon inside. Here, we will be having circle inside the polygon. We have some important points. Here, a straight line drawn from the center of a circle to bisect a chord is at right angles to the chord. Here, in this case, AB is a chord. AB is a chord and OM is a line that is drawn to bisect AB. What does OM do? OM divides the line AB into 2 equal halves, which means OM divides AB into 2 equal halves. Okay. OM divides AB into 2 equal halves, which means AM will be equal to AB. So, according to this statement, if a line bisects a chord, then it will be at right angles. Okay. This angle will be right angle. Now, we can prove this. So, you don't need the proof. Just I'll give you an idea. If you are considering these 2 triangles. Okay. When you take the measure, this is a common side. We have found that AM and BM are equal and OA and OB will be equal because they are the radius of circle. So, SSS criteria we can use and these 2 triangles will be similar triangles. Now, if the triangles are similar, then the corresponding angles should be equal. So, this angle and this angle will be getting equal. Since this is a straight line, the sum of these 2 angles will be equal to 180 degree and they are equal. So, if this is x, x plus x should be giving us 180 degree. That is 2x is equal to 180 degree and x will be equal to 90 degree. So, this is a required proof. Now, the converse of this statement is also true. That is, if you are drawing a perpendicular, the perpendicular to a chord from the center of the circle bisects the chord. So, first statement we have said that a line that is drawn from the center, if it bisects the chord, then it will be at right angle. It will be perpendicular. That is, OM will be perpendicular to AB. The converse of the statement is, if a line is drawn perpendicular to the chord, then the line will bisect the chord. Clear? Next point, Equal chords of a circle are equidistant from the center. Here we have two chords AB and CD. They are equal chords, which means the length of AB will be equal to the length CD. Okay. They are equidistant from the center. The distance of AB from the center is OM and the distance of CD from the center is ON. Equidistance means OM will be equal to ON. Okay. Now the converse of this statement. Chords of a circle equidistant from the center of the circle are equal. Here we have chords AB and CD given that they are equidistant from the center, which means OM is equal to ON, implies they will be of equal length, which means if they are at equal distance from the center, then the length of the chord will be equal. AB will be equal to CD. Okay. So, if AB is equal to 4 centimeter, then CD is also equal to 4 centimeter. If their distance, if I am taking the distance as 1.5 centimeter, 1.5 centimeter from the center. AB is at a distance 1.5 centimeter and CD is also at a distance 1.5 centimeter from the center. In that case, if the measure of AB is equal to 4 centimeter, then CD will also be equal to 4 centimeter. Clear? Okay. Now, if I am considering another circle. So, this is my circle with center O. Okay. Here I am taking a small chord AB and a big chord CD. What is the relation between AB and CD? AB will be less than CD because AB is a small chord and CD is a big chord. What is the distance from center? AB distance from center. AB is at a distance of OM from the center. Okay. Similarly, distance of CD is ON from the center. The measure OM is greater than ON. Yes. OM greater than ON. What does this mean? That is, when the length of chord increases, its distance from center decreases. If I am having a chord here, this is a small chord. It is at big distance from the center. Here our CD is a big chord, the length of the chord CD and the distance from center is very small, right? ON is very small. Okay. So, the statement is greater is the size of a chord, smaller is its distance from the center. Its distance from the center will be small. Understood this? Any chords taken when the length of chord is higher, it will be at smaller distance. Yes, if I am taking the diameter is the largest chord. What is its distance from the center? It is lying on the center. It passes through the center. There is no distance. Distance is 0. Yes. Now, if you have one point, with this one point I can draw n number of circles, right? I can draw many circles of different radius. If I am taking 2 points, still then I will be able to draw circles. I can draw many circles which passes through these 2 points. But if I take 3 points, do you think I can draw n number of circles? So, there is only a single circle that passes through all the 3 points such that the points should never lie on a straight line. Okay. 3 points, if I am taking 3 points, if they lie on the straight line, can I draw a circle then? No, right? I cannot draw the circle because there should be a center. The distance from the center will be different. So, I cannot form a circle in that case. There is always only one circle which passes through 3 points. Okay, 3 points which are not on a straight line. Understood this? So, these are some basic ideas. Now, we will be discussing about arcs and segments of a circle. What is an arc? Arc is a part of the circumference of a circle. Circumference of circle. Circumference is a perimeter of circle. Yes, the measure of the total length of the circle is called the circumference of circle. Here when you consider the circle has a center O. Now, when I take this points A and B, I am drawing a line connecting A and B. This line is called the chord. Okay. Now, here the circumference of circle, this point A and B divides the length of the circle or the circumference of circle into two parts. Yes, AQB is one part. The small part is AQB and APB is the bigger part. Okay. So, in simple words, we can define AQB. AQB is the small part of the circumference of circle and APB is the bigger part of the circumference of circle. This AQB we call the minor arc. Minor means small. Minor arc. And the bigger arc APB we call the major arc. Okay, understood what minor arc and major arc is? So here if you have a semicircle means the diameter will form a semicircle. In that case, the measure of the minor arc will be less than that of semicircle and the measure of the major arc will be greater than that of semicircle. So semicircle means it will be from here to here. Okay, here to here you will be having the semicircle. We have APB arc, the major arc from here to here, which means APB will be greater than the measure of the semicircle. Understood what minor arc and major arc are? Now, let us see what are segments. We had a chord AB. We had taken a chord AB. What does AB do? This chord AB divides circle into two parts. Yes, the circle is divided into two parts. This is one portion and this is the second portion. Here I have shaded small region and here I had to shade a bigger region, which means the arc AQB and the chord AB is forming a portion. The arc APB and the chord AB is forming a portion. A chord divides the circle into segments. So, segment is a part of circle bounded by an arc and a chord. Here, this arc AQB and AB makes a segment and the arc APB and AB makes another segment. Now, we have minor arc and chord. So, minor arc and chord together will give us the minor segment. Minor segment. So, from this figure it is clear that this is a small portion, right? So, small portion, therefore, minor segment. What about this? This will be the major segment. Major segment is formed by the major arc and the chord AB. Major arc and the chord AB forms the major segment. Is it necessary that the figure is always like this? What if you have another circle and I am having a chord CD here? In this case, we had, in the upper portion, we had the minor segment and lower portion, we had the major segment. Here in this case, upper portion, can we call this as a minor segment? No, right? This is a bigger portion. Yes, CD is the chord and here we have the major arc. Major arc and the chord will make the major segment. In this figure, this is major segment and this is minor segment. So, it is not necessary that the minor segment always comes above and the major one comes below. It can be wherever it is, okay, depending on the area it has covered. That is depending on whether it is formed out of the minor arc or major arc. We can say it is minor segment or major segment. Understood this? Next, we will be discussing some theorems. So, first theorem is the angle which an arc of the circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. So, here we have a big statement, but the concept is very simple. Here, if I am considering this arc APB, APB is an arc. Okay, this arc APB, or if I am joining this A and B, I will be getting a chord AB. Okay, so when I draw this AB, I will be getting two arcs. This is the minor arc APB is the minor arc and ACB is the major arc. So, minor arc will form the minor segment and major arc will form the major segment. Here, when you take this arc AB, APB is subtending an arc angle at the center. Yes, AOB. AOB is angle subtended at center. Okay, the same arc AB subtends another angle on the circumference of circle. Yes, C is a point which lies on the circumference of circle. So, ACB is an angle that is subtended by the same arc APB or the same chord AB. Yes, angle ACB is angle subtended at the circumference. Okay. Now, we are going to relate AOB and ACB. There is a relation between AOB and ACB. Angle AOB will always be 2 times angle ACB. This is what the statement means. Angle AOB will be equal to 2 times angle ACB. Yes, AOB is the central angle or the angle subtended at the center and ACB is the angle subtended at a point which lies on the circumference of circle. Clear? So, this is the relation. If you want ACB, then angle ACB will be equal to AOB divided by 2. So, it is clear that ACB is an angle that is subtended on the major segment. Yes, this is a major segment. So, ACB is angle which is subtended in the major segment and the measure of ACB will always be less than AOB. Okay. Here, if you consider this as a cyclic correlator, that is ACBP, if I am joining this. Okay. This is a cyclic correlator. From here, it is clear that ACB is an angle which is less than AOB. What about this APB? APB is an angle that is subtended in the minor segment. Okay. What about APB? APB is larger, right? The angle APB is more than the angle AOB. So, about this we will be discussing later. Now, if I am saying that AOB, if AOB angle is given as 2x, then what is the measure of ACB? If angle AOB is equal to 2x, then angle ACB will be equal to 2x divided by 2, half of angle AOB, 2x by 2 which is equal to x. So, let us take an example. If I am giving you angle AOB is equal to 70 degree. What is the measure of AOB? I am giving 70 degree. What is the measure of ACB? What is the measure of ACB? ACB will be half of AOB. So, here AOB is 70 degree. Then ACB will be equal to 70 degree by 2 which is 35 degree. If I am giving you angle ACB, ACB is an angle that is subtended on the circumference of circle. ACB is equal to 20 degree. What is the measure of AOB? AOB will be 2 times ACB. If ACB is equal to 20 degree, then AOB will be equal to 20 degree into 2. 20 degree into 2 and that is equal to 40 degree. Okay. So, if central angle is given, we can find the angle which the same arc subtends on the circumference of circle, and if the angle subtended on circle is given, you can find the central angle for the same chord. Remember, the chord should be same. Here AB is the chord or the arc APB. Okay, understood this theorem? Next theorem, angle in the same segment of a circle are equal. So, here we have a figure. Yes, same we have arc AB here. Okay, this APB is a arc. APB subtends angle AOB in the center. Here we have two other angles given, that is ACB and ADB are subtended by the same arc APB on the circumference of circle. Okay, so we have studied the relation between AOB and ACB. Yes, in the previous theorem, we have studied the relation between AOB and ACB. We have angle AOB equal to 2 times angle ACB. What is the reason? Angle subtended at the center by an arc will be equal to 2 times or twice the angle subtended at a point on the circumference of circle. Okay. Now, if AOB is equal to 2 times ACB, what about this ADB? ADB is also an angle subtended by the same arc on the circumference of circle. Therefore, the measure of AOB should be equal to 2 times ADB as well. Yes. AOB should be equal to 2 times ADB. Yes. If ACB is equal to half of AOB and ADB is equal to half of AOB, then we can say that ACB and ADB are equal. Yes, here we have left hand side equal, then right hand side should also be equal. Yes, therefore 2 times ACB equal to 2 times ADB implies ACB equal to ADB. Okay. If this measure I am taking as 80 degrees, if AOB is equal to 80 degrees, then what is ACB? ACB will be equal to 40 degree, half of 80 degree. What about ADB? ADB is also half of AOB. Then ADB is also equal to 40 degree. So, we are getting ACB equal to ADB. So, do we really need the central angle? No, right? If we have the measure of any angle that is subtended on the circumference of circle, we can find all other angles that is subtended on the circumference of circle. Yes, if ACB is equal to 40 degree, then we are getting ADB also equal to 40 degree. If I am giving you ACB equal to 30 degree, what is the measure of ADB then? What is ADB? ADB will also be equal to 30 degrees. Yes, ADB will be 30 degrees. Now, I am taking another point. This is my point E. Okay. Here, an angle is made by arc AB at point E. What is the measure of AEB is my question. What is AEB? AEB is a point, is an angle that is subtended at a point E on the circumference of circle. We have ACB, ADB and AEB equal. Okay. Any point that is made by the arc APB, the angle subtended will be equal. If this is 40 degree and this is 40 degree, AEB will also be equal to 40 degree. If I am taking another point F here, okay. Here we have an angle AFB. What is the measure of AFB then? AFB will also be equal to 40 degree. Yes, wherever we get a point and we take an angle that is subtended by the same arc or the same chord. If I join A and B, I will be getting the same chord. Then the angle measure will be same. Here AFB, ACB, ADB and AEB are all angles that belongs to this major segment. So, angles belonging to the major segment will be having the same measure. Okay. So, when you take a chord, the chord makes two segments, minor segment and major segment. Yes. So, here the 2 points A and B will remain the same. Then, all the angles that are subtended by this chord will be of equal measure, or all the angles that belongs to the same major segment will be having the same measure. So, here we don't need the central angle in order to find the angle subtended. If any one measure is given, we can find all other angles that belongs to the same major segment. Next theorem is angle in a semicircle is a right angle. How do we get a semicircle? Here O is the center of circle and AB is a line that is passing through the center of circle. Okay. A is a point on circle and B is also a point on circle. Therefore, AB is a chord. What is the peculiarity with AB? AB is a chord that is passing through the center, which means AB is our diameter. AB is the diameter. Okay. So, the diameter divides the circle into two equal segments. Yes. Here we have two equal halves and we call this the semicircle. So, the arc and the chord together makes the semicircles. Okay, in a semicircle, if you take a protractor is a semicircle. What is the total angle measure? Angle measure will be equal to 180 degree, right? So, angle AOB is equal to 180 degrees. Now, this is an arc. Yes, AB is a chord. The angle subtended by the chord at center is equal to 180 degree. The chord AB or the arc AB subtends an angle AOB at the center and the measure of the angle is equal to 180 degree. What is ACB then? ACB is an angle subtended by the same chord AB on the circumference of circle. Yes, ACB, this angle. We have to find the measure of this ACB. What is ACB then? ACB will be equal to AOB divided by 2 according to the first theorem that we have discussed. Yes, ACB will be equal to half of AOB. AOB we have, AOB is 180 degree. 180 degree divided by 2 which is equal to 90 degree. Therefore, this is a right angle. Measure of ACB will be equal to 90 degree. Okay. Now, if I draw, this is again an angle that is subtended by the same chord AB on the circle. What is the measure of this angle? I have put this angle to one corner. Yes. Since it has come to corner, will it be less than 90 degree? Do you think? No, right? Anywhere in the circle, if the angle is subtended by the chord AB, then the measure will be equal to 90 degree. If I am taking like this measure will be equal to 90 degree. If I am taking like this, here again will be getting 90 degree. So, the statement is clear. Angle in a semicircle is a right angle, or the angle subtended by the diameter will always be right angle or will be equal to 90 degree. Clear? So, this is the statement. So, theorem is clear, right? We know that the angle in a semicircle is the right angle. This measure is 90 degree. Now, I am taking two other points. This is my point D and this is my point E. Okay. I am joining AE and EB. Similarly, I am joining AD and DB. Yes. ADB, ACB and AEB are angles subtended by chord AB. Yes. Now, just check these angles. What is the relation between these angles? We know this angle ACB is equal to 90 degree because this angle belongs to the semicircle or is subtended by the diameter. Now, E is a point outside circle. Okay. So, when we have a point outside circle and we are forming an angle, what will be the angle measure? When you just look at this figure, it is clear that the measure of AEB will be less than 90 degree. Yes, it is shrinking, right? The angle is becoming small. What about ADB? Angle ADB. D is a point which lies inside the circle. What is the measure of ADB? ADB will be greater than 90 degree. Okay. So, when you consider points outside the circle and inside the circle and find the angles formed by the same diameter AB, then the measure of AEB will be less than 90 degree and ADB will be greater than 90 degree. Now, I will be giving you two values. We have three angles, 30 degree, 90 degree and 120 degree. Okay, 30 degree, 90 degree and 120 degree. Which angle can be 120 degree? AEB, ACB or ADB. Which angle is 120 degree? Angle ADB will be equal to 120 degrees. What is the reason? ADB is always greater than 90 degree. So, ADB cannot be equal to 30 degree nor ADB can be equal to 90 degrees. Okay. What about 30 degree? Which angle measure is 30 degree? Angle AEB. Angle AEB B will be equal to 30 degrees because we know that angle AEB is less than 90 degree. Yes, here 30 degrees less than 90 degree. Therefore, AEB can be equal to 30 degree. Clear? Next, we are discussing the cyclic properties. So, here we have a theorem to study the opposite angles of a cyclic quadrilateral. Quadrilateral inscribed in a circle are supplementary. What is a cyclic quadrilateral? So, here we have a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. Why? Because these points, the vertices of the quadrilateral lie on the circle, touches the circle or inscribed in a circle. Okay. So, here we have A, B, C, D is a cyclic quadrilateral. Here we have the circle center O. Okay. Now, AOC is an angle that is subtended by the arc ABC at the center and ADC is an angle that is subtended by the same arc ABC on the circumference of circle. So, we know the relation between AOC and ADC we have studied in the first theorem. What is the relation? Angle AOC is equal to 2 times angle ADC. Okay. Here, we are going to have a relation between ADC and ABC. ABC and ADC are the opposite angles of the cyclic quadrilateral. So, in the theorem, it is said that the sum of opposite angles will be equal to 180 degree or pair of opposite angles will be supplementary. Yes, therefore, angle ADC plus angle ABC will be equal to 180 degree. Now, here AOC, if AOC is equal to 2x, then what is the measure of ADC? ADC will be equal to x. Okay. If AOC is 2x and ADC is equal to x, can we find the value of ABC? What is ABC if I am taking this chord? AC is a chord. AC divides the circle into 2 segments. So, this is the major segment and this is minor segment. ADC is an angle that belongs to the major segment and ABC is an angle that belongs to the minor segment. Yes. So, here it is clear that this angle AOC is always greater than ADC. ADC because AOC is equal to 2 times ADC. Yes. What about ABC? From the figure it is clear that angle ABC will be greater than angle AOC. Yes. This is a bigger angle. Now, what is the measure of ABC? We have angle ADC plus angle ABC equal to 180 degree according to the theorem. Then angle ABC will be equal to 180 degree minus angle ADC. 180 degree minus angle ADC. Now put the measures. 180 degree minus what is ADC? ADC is this angle which is x. Therefore, angle ABC is 180 degree minus x. If you know this angle, we can find the opposite angle. Just we have to subtract this angle from 180 degree. Okay. If I am giving you angle ADC is equal to 40 degree, what is the measure of angle ABC? What is ABC then? If ADC is equal to 40 degree, what is ABC? ABC will be equal to angle ABC equal to 180 degree minus 40 degree which is equal to 140 degrees. Okay. This question I am giving angle AOC is equal to 80 degrees. Okay. I am giving AOC is equal to 80 degree. Find the measure of angle ABC. How to find ABC? If AOC is known, we can easily find the value of ADC. What is ADC then? ADC will be equal to half of AOC, that is half of 80 degree, and that is equal to 40 degree. If ADC is 40 degree, we know that ABC will be equal to 180 degree minus 40 degree and that is equal to 140 degrees. ABC will be equal to 140 degree. So the theorem is clear. What is the statement? The opposite angles of a cyclic quadrilateral are supplementary. You know what a cyclic quadrilateral is? So the opposite angles when taken 180 degrees. Clear? Next theorem. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angles. What are interior angles and exterior angles? If you take a triangle. So this is a triangle. Okay. These angles are called interior angles inside the triangle. And these angles are called exterior angles. These three angles. 1, 2, 3. These three are exterior angles. That is, they lie outside the triangle. Okay. Now, this is a quadrilateral. Same is the case. So, here A, B, C, D. We have this, and this are interior angles. And here, when you extend this line, this angle will be an exterior angle. There is a relation between the exterior angle and interior opposite angle. So, opposite to this angle, here the interior angle that comes with this angle, this exterior angle is angle B. Opposite to B, we have D. Yes, the relation between D and exterior angle B. So, this is interior angle B and this is exterior angle B. There is a relation which means both of these angles will be equal. Now, what is the reason? For a cyclic quadrilateral, we know the sum of opposite angles is equal to 180 degree. Our previous theorem. Yes, therefore, angle CDA plus angle CBA will always be equal to 180 degree. Sum of angles opposite in a cyclic quadrilateral is 180 degrees. Okay, is 180 degree. Okay. Now, this angle I am taking as some x. This x and this angle as y. Okay. We have x plus y is equal to 180 degree, which implies y is equal to 180 degree minus x. Okay. Now, when I take this straight line, you have two angles. I am taking this exterior angle B as z. What is y plus z? Y plus z will also be equal to 180 degree linear pair. Okay. The angles on a straight line, sum of angles on a straight line will be equal to 180 degrees. Therefore, y plus z is equal to 180 degree. Then what is z? Z will be equal to 180 degree minus y. Okay. Here we have x plus y is equal to 180 degree and y plus z is also equal to 180 degree. If x plus y and y plus z are equal to 180 degree, we will be having x plus y is equal to y plus z. Cancelling y, we get x is equal to z. What is x? X is this interior angle and z is this exterior angle. Exterior angle is equal to the opposite interior angle. Clear? So, we will be using this statement also in solving the problems. We have studied all the important concepts for today. Let us take an example. Example 1, in the adjoining figure, PQ is equal to PR and angle PRQ is equal to 70 degree. Find QAR. Where do we have QAR? This is QAR. Okay. From this figure, it is clear that angle QAR and angle QPR will be equal. What is the reason? Here we have a chord QR. QR subtends angle QAR on the circle and QPR on the circle. We have studied angle subtended by the same chord will be having the same measure. Yes, angle subtended by the same chord will be equal. Therefore, we will be having QAR equal to QPR. First, what is given? In this question, it is given that PQ is equal to PR. Okay. And the known angle, that is PRQ is equal to 70 degree. From figure it is clear. From figure we have angle QAR is equal to angle QPR. What is the reason why QAR and QPR are equal? Angle subtended by same chord are equal. Okay. Now, how to find QPR? We don't know the value of QPR. We need to find the value of QPR. Is there anything that I can do to find QPR? Only if I get QPR, I can get the value of QAR. How to find QPR? We have PQ is equal to PR, which means angles opposite to them will also be equal. Angle opposite to equal sides are equal. Here we have the measure PRQ. PRQ is equal to 70 degree. What is PRQ? PRQ is an angle that is opposite to PQ. We'll be having PRQ equal to angle PQR. Since PQ and PR are equal, angle opposite to PQ is PRQ and angle opposite to PR is PQR. They will be equal. PRQ is equal to PQR. Reason? Angles opposite to equal sides are equal. Equal sides are equal. Okay. Then what is the measure of angle PQR? PQR will also be equal to 70 degree. PQR is equal to 70 degree. Now consider the triangle PQR. In triangle PQR, what do we have? Two angles are known. We also know that the sum of all the interior angles of a triangle will be equal to 180 degree. Yes, therefore, angle PQR plus angle QPR plus angle PRQ is equal to 180 degrees. What is PQR? PQR is 70 degree plus QPR. QPR we don't know. Angle QPR plus PRQ. PRQ is again 70 degree is equal to 180 degree. Okay. Therefore, QPR is equal to 180 degree minus this 70 plus 70. 70 plus 70 is 140. We have to subtract this 140 from here. Taking to the left side, 140 degree. QPR is equal to 40 degrees. 180 minus 140 is 40 degree. We get this angle 40 degree. If QPR is equal to 40 degree, then QAR also will be equal to 40 degree. Yes, angle QAR is equal to 40 degree. What is the reason? We have said this before. Angle subtended by same chord are equal. So, when you get a question, what you have to do is, you have to relate the angles that we need to find with the other angles that is given. Here, to relate QAR, we can relate QAR to QPR because here we have a chord QR. The angles are subtended by the same chord QR. Then we'll try to find this value. To find this value, we'll be considering this triangle. Then, in this triangle, we needed to find this angle. To find this angle, we had equal sides. Angles opposite to equal sides are equal. With this idea, we have determined this angle from which we could determine the value of QAR. Clear? Next example. The given figure shows a circle through the points A, B, C and D. If angle BAC is equal to 67 degree, find DBC plus DCB. DBC is this and DCB is this angle. It is given that angle BAC is equal to 67 degree. Okay. Now, when you consider this chord BC, this chord BC subtends angles BAC and BDC on the circle, which means these two angles should be equal. angle subtended by the same chord on the circumference of circle will be equal. We have studied this theorem. Therefore, we are having angle BAC equal to angle BDC, angle subtended by same chord. Okay. So, we are getting this angle equal to 67 degree. That is angle BDC equal to 67 degree. Okay. Now, consider this triangle BDC. In triangle BDC, we have the sum of interior angles will be equal to 180 degree. Here, we have angle DBC plus angle DCB plus angle BDC equal to 180 degree. These three are the angles of the triangle BDC. Okay. Now, we have one value given which is BAC. BAC is equal to 67 degree, from which we obtain BDC is also equal to 67 degree. BDC is 67 degree. Okay. Then we have angle DBC plus angle DCB, and that is equal to 180 degrees. Therefore, angle DBC plus angle DCB will be equal to 180 degree minus 67 degree. Angle DBC plus angle DCB is what we have to find. Okay. Therefore, angle DBC plus angle DCB equal to 180 degree minus 67 degree, you will be getting 113 degree. So, this is the required angle. Okay. Angle DBC plus angle DCB is equal to 113 degree. Clear? Example 3. The given figure shows a triangle ABC with angle BAC is equal to 56 degree and ABC is equal to 64 degree. Bisectors of angles A, B and C meets the circumcircle of the triangle ABC at points P, Q and R respectively. Find the measure of QPR. We have to find this angle. Okay. Here, what is given? Given angle BAC is equal to 56 degree and angle ABC is equal to 64 degrees. Okay. When you consider triangle ABC, consider triangle ABC. So, ABC has three angles, angle ABC, ACB and BAC. Yes. In triangle ABC, angle BAC plus angle ABC plus angle ACB will be equal to 180 degree. Sum of the interior angles of triangle will be equal to 180 degree. Now, we can find the value of ACB. Yes. What is ACB then? We have BAC. BAC is 56 degree. ABC is 64 degree and ACB when added you will be getting 180 degree. Therefore, ACB is equal to 180 degree minus 56 degree plus 64 degree. 180 degree minus 56 plus 64 you get 120 degrees. And ACB is equal to 180 minus 120 which is 60 degree. ACB, this whole angle measure is equal to 60 degree. Now, what is given in the question? In the question, it is given that bisectors of angle A, B and C meet the circumcircle of the triangle ABC at point PQR. We can find PQR. So, PQ is a bisector, PR is a bisector. Yes. So, on bisecting, you will be getting bisection mean what does bisection mean? It means the angle will be divided into two equal halves. So, here when a bisection BQ is a bisector, since BQ is a bisector, we will be getting ABQ and CBQ equal. Okay. Here RC is a bisector, which means ACR and BCR will be equal. Again, PA is a bisector, which means BAP and CAP will be equal. Here we have to find angle QPR. To find QPR, how to find QPR? QPR is made up of angle QPR is equal to QPA, angle QPA plus angle RPA. Yes, RPA. If we are able to find separately the values of QPA and RPA, on adding them we will be getting the value of QPR. Yes, how to find the value of QPA? Angle QPA. This is QPA. QPA will be equal to QBA. QBA. When you are considering this chord. Okay. When you consider the chord AQ subtends angle QPA at this point P and QBA at this point B. Angle subtended by same chord. Angle subtended by same chord are equal. So here we know the measure of angle ABC and QB bisects ABC. Then what is the measure of QBA? Angle QBA will be half the angle ABC. Since bisection is happening, we know the measure of ABC. What is ABC? ABC is equal to 64 degrees. Half of 64 degree, that is equal to 32 degrees. Okay. QBA, this angle will be equal to 32 degree. If this is 32 degree, then QPA, this angle will also be equal to 32 degrees. Yes, angle QPA will be equal to 32 degrees. We have determined one angle. Now we have to find RPA. How to find RPA? How to find RPA? Angle RPA will be equal to, this is RPA, RCA. It will be equal to angle RCA. Same reason. Here, when you consider a chord RA subtends RPA, angle RPA at point P and RCA at point C. Therefore, their measure will be equal. RPA will be equal to RCA. Now, how to find RCA? Here we have ACB. Total angle ACB we have determined is equal to 60 degree. Angle ACB is equal to 60 degree, which means angle RCA is half of angle ACB since this angle is bisected by RC. Okay. Half of 60 degree and that is equal to 30 degrees. 30 degrees is a measure of RCA. If RCA is equal to 30 degrees, then RPA will also be equal to 30 degrees. Angle RPA is equal to 30 degrees. Okay. So, we have got the values of RPA and QPA. We have angle QPR is equal to angle QPA plus RPA. Now put the values. QPA we have determined is equal to 32 degrees. 32 degrees plus RPA. RPA is this angle which we have determined is 30 degree. 32 degrees plus 30 degree, we get 62 degrees. So 62 degrees is the measure of this angle, this total angle QPR. QPR is equal to 62 degrees. 62 degrees. Understood this? That's all for today. In today's class, we have discussed many concepts and theorems from chapter circles. We have studied the concept with examples and solved questions from exercise 17A. There are many more questions which we will be solving in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.